Hi, my name is Schuchmann, and in this talk I want to show you how you can use GAMS, the General Algebraic Modeling Language, to quickly build optimization models and to instantly turn these models into fully fledged and interactive applications with zero programming. I will use two pieces of software in this talk. The one is the GAMS system. GAMS comes with our new IDE GAMS Studio, which I will use, and to deploy the GAMS model later on, I will use the new tool GAMS MIRO Desktop. You are invited to download both under these links and try it out yourself. Alright, let us start with one introductory slide about the company itself. GAMS has its roots at the World Bank back in 1976 and it went commercial 11 years later. In fact, GAMS was the first software system to combine the language of mathematical algebra with traditional concepts of computer programming in order to efficiently describe and solve optimization problems. Today, GAMS has offices in the US and in Germany and customers all over the world. So much about the company. Let's now get right into it. And since we are very limited in time, I will not develop a GAMS model from scratch, but rather show you a ready-to-use model and explain a few basic things about the modeling language. Our model is a simple transportation problem by Danzig. So we have some canning plants in Seattle and in San Diego with a certain production capacity, and we have markets with individual demands. The goal of this model is to minimize the overall transportation costs subject to the demand satisfaction at the markets and subject to the supply constraints. The mathematical formulation now looks like this. We have some indices I and j for the plants and the markets. Our given data is A, the supply of commodity of plant I in cases. We have a demand B for a commodity at market J, and the cost C per unit shipment between a plant and a market. Our decision variable X is for the shipment's decision, and we have three constraints. The last one here is the objective function, where we want to minimize the overall transportation costs. These are calculated by multiplying C, the costs per unit shipment between the plant and market, by X, the amount of commodity to ship between these cities. And then we need to observe the supply limit at the plant I, and this is done by this. So all shipments from a market must be lower or equal to its capacity, and we need to satisfy the demand at a market, meaning all shipments to a market must be greater or equal to its demand. Now this can be easily formulated using the GAMS language. We see a few basic language elements here, like the sets, parameters for the given data we have here, variables X and Z, which is the objective variable, and our three equations. And you can see that this is very similar to the mathematical notation. You can almost read these equations the same way you read them on the left side here. For example, the demand constraint here, we can read it like this. For each market J, we need to summarize the shipments of all plants I to this market, and this sum must be greater or equal to its demand B. Right, so the use of concise algebraic descriptions makes the model highly compact and with a logical structure. After these equations, we have the model statement. The model statement is used to collect equations into groups and to label them so that they can be solved. Our model here is called transport, and by using the keyword all, we say that we want to use all equations we declared. Once a model has been defined using the model statement, we have now the solve statement here. And the solve statement prompts GAMS to call one of the available solvers for the particular model type. Here, transport is again the name of our model, LP is the model type, minimizing the direction of optimization, and z is the objective variable. Okay, we will come back to this model in a minute, but before I want to say a few words about a GAMS model in general. So a GAMS model and the operating system are independent of each other, meaning these models can be used between platforms easily. Also, you can switch the solver to use very easy. When you install the GAMS system, some default solvers are used for all model types available. And these solvers are used if you, as the user, do not specify anything else. And one of many ways to switch the solvers is by using an option statement. For example, here I say I want to use the solver CBC for my LP models. This is one of many ways to switch the solvers. And you can find out more about the solvers available in GAMS under this link. Next, the independence of model and data. So model and data are independent of each other, and the data can come from any data source like CSV files, spreadsheets, databases, or the GDX files, which are the GAMS data exchange files. Last but not least, the independence of model and user interface. Well, intuitive deployment and visualization options are becoming increasingly important nowadays. The reasons for this are that end users of optimization software are very often no modeling experts, and there is a need for easy-to-use tools to visualize data and to compare results. GAMS has been designed to interact with other systems, so there are several expert level and object-oriented APIs for Python, for Java, C++, and many more. And you can use these APIs to build your own sophisticated applications on top of a GAMS model. The problem might be that there might be a lot of programming required to get to such an application. A relatively new approach is GAMS MIRO, our new deployment environment for GAMS models. And the idea of GAMS MIRO is that you do not need to program anything if you don't like to, but you rather build your first application within minutes and then develop it further step by step by configuring it. So we want to configure instead of program. So what is this GAMS MIRO? MIRO is an interactive interface for GAMS models that is built on top of your model and which you can use via any modern web browser. The model itself becomes a kind of black box for the end user because the user doesn't see the model at all, but only the MIRO application. One of MIRO's goals is that the important non-modeling steps you have very often, like for example visualizing results and to make a model accessible to others and to illustrate the optimization problem, these steps should not take too much time so that you can concentrate more on the modeling itself. You can see a MIRO application as the face of a GAMS model so that you can interact with. You can use widgets like sliders and drop-down menus that allow you to feed the model with exactly the data you want to use. And you can use a lot of charting tools, several different charting tools to visualize your data and your results. Also, MIRO comes with a convenient scenario and data management system that allows you to easily generate and save scenarios and to compare them. Okay, now I want to show you what needs to be done in order to get such a MIRO application. For this I will use GAMS, including the IDE GAMS Studio, as well as GAMS MIRO Desktop. And if you like, you can now download and install both before continuing this video. Okay, I just opened GAMS Studio, and what you see here is the welcome page of Studio. And the transportation model I showed you is part of the GAMS model library that comes with the GAMS installation. You can get this model by clicking on GAMS and then on Model Library Explorer, or by clicking on F6. And In this model library you find hundreds of interesting GAMS models, and for the transportation model you just need to search for transport, and transport in this case without an A. So transport, and we open this one. And this is almost the same model you just saw before. We now have some data for our symbols A and B here. And we have two new symbols. We have a table D for the distance between the cities. And we have a scalar F for the freight in dollars per case per 1,000 miles. And we use these two to calculate the transportation costs between two cities. We can solve a model in Studio by clicking on this green button, on this green Run button here. And since this is a very small model, it takes a very short time. And while solving, Studio shows us the GAMS process log on the right side here, including the solver output and the objective function value here, which is in this case an optimal solution. After solving, GAMS also gives us the listing file. This listing file contains things like the compilation and execution output, listings of all equations and variables, as well as the solution report here. But let's not go too much into detail here, but rather find out how to get a Miro application up and running. For this, you maybe should first make sure that GAMS Studio knows about your Miro installation. For this, go to File and Settings and check the path in the Miro tab here. This should be the path where you installed GAMS MIRO. And if it's not the correct path, you can just modify it here. So, when we want to have a Miro application for our model, the first thing we need to do is we need to tell Miro which symbols we would like to see in our application. We call this the GAMS MIRO data contract. I can set up this data contract by annotating my model by using certain tags. And I annotate the symbol declaration. So for input symbols, I use tags, namely on external input and off external input. And all symbols that are declared between these two tags will be part of the GAMS MIRO data contract and thus be visible in my Miro application as input data. So symbols we use to feed the model for a model run with data. The same is true for output symbols. I can use the tags on external output and off external output. So on external output and off external output. It's the same as for the input symbols. All symbols declared between these tags will be visible in Miro as my output data. So as a small task, you can now pause this video and tag those symbols in this model which you want to see in your Miro application. You can use symbols of any type. Okay, let's do this together now. I want to see all these symbols here as input symbols for my Miro application. So what I can do is I write on external input right before the first symbol declaration. So on external input here, and after the F here I write off external input. I can use these tags multiple times within a model. For my results, I want to see these variables here. So I write on external output and off external output. And that's it. I can launch my first Miro application by clicking on Miro and on Run Base Mode here. During the startup, Miro imports some default data it can find in the model, and this default data is available in the Miro internal database, so we can load it directly after the start. And this is what a Miro application looks like. We have our input section here, where we have our symbols for the capacity, the demand, the distance, and the freight. And we can play around with the data if we like. So let's change this to, let's say, 85. And I click on Solve Model, which triggers the GAMS run in the background. When clicking on the Solve button, Miro switches to the GAMS interaction section here, which shows the log file and the listing file I just showed you in Studio. And after the model run, Miro switches to the output section, where we can see our variables x and z. So besides the normal tabular data representation, a pivot view is available per default for all input and all output symbols. By clicking on this icon here, I can switch the view. With this pivot tool, I can already get some basic charts. So let's just filter our header here containing the level of my variable. I can put the canning plants, for example, here and say I want to see a bar chart for this data. And as you can see, this is already some basic chart we can have just by setting up the Miro data contract, and that's all we did so far. Okay, this is the most basic Miro application you can get by just adding these tags I just mentioned. What we want to do now is do some configuration of our application. So let me close this now. Besides the Miro base mode, we also have the configuration mode. This configuration mode allows us to do all kinds of customizations to the Miro interface. So what we can do here is setting some general settings, like changing the logo, which is visible here in the upper left corner. We can set the color theme to use. We can set some table settings here, and we can configure widgets. So I want to configure a slider for our scalar freight. This is already selected here as the default widget. So I can choose a label here. Let's say select freight. I can set the minimum value of the slider. Well, 1 would make sense. And the maximum value, let's say 200, and a default value, let's say 90. The step size of 1 is just fine. And I can click on Save, and that's it. Now we have configured a slider for our scalar f. In this section here, we can configure graphs. And for the graphs configuration, I can load the same default data I also loaded in the base mode before. And this data is then used for a live preview of my graph configuration, which can be very helpful. So in Miro, I have some basic chart types available here, like pie charts, bar charts, line charts, and so on. And so this transportation model is very limited in terms of visualization options. So what I could do now is I could configure this pivot tool we already saw, and I could configure the default view one would see after a startup. Of course, I don't want to do this for my symbol A here, but for my symbol X. So I select the pivot table tool here. I can just drag my default view here. So the header was in the filter, and I want to filter the level of my variable, my canning plants in the header here. And I want to see a bar chart per default. And that's it. And I click on Save, and I configured this view for my symbol X. Now let's see how this looks like in our Miro application. So I close this again and start the Miro base mode. Okay, looks basically the same. I can load my default data again, and we now have a slider for our symbol freight. I can set some value here and click on Solve again. Let's see how our results look like. The default view now shows the bar charts we just configured. All right. Back to the GAMS model. So to be honest, this model is well suited for an introduction like this, but it might not be too well suited for the real world. For example, one thing that could make sense for a transportation problem is a minimum shipment constraint for our goods, meaning we should only be allowed to ship goods when our variable x exceeds a certain quantity. We can achieve this by adding an equation to our existing model. And thinking of our MIRO application, I can imagine setting a value for this minimum shipment in MIRO in the form of a widget, like again a slider maybe, which is then used for the model run. So in this GAMS model, I start by adding a new scalar value for the minimum shipment to the model. So I add this scalar here, let's call it min s for the minimum shipment. And now as a next task for you, you can pause this video again and try to extend this model by this minimum shipment constraint. Okay, let's do this together now. So let's maybe first change this to min s, that makes more sense. We add a default value here for our scalar. Let's say the minimum shipment should be 100 per default. And now, for this minimum shipment constraint, we need a binary variable, which is 1 if we ship from plant I to market J, and which is 0 otherwise. So let's declare this binary variable here. Binary variable. Let's call it ship from I and J. We can also add some explanatory text here. Let's say it should be 1 if we ship from I to J, and otherwise 0. Now let's add the equation in this equation block here. So let's name this equation min ship, which should be true for all plants and markets, and some explanatory text, minimum shipment. Now, how does this equation look like? Well, we want to say for all plants and markets, we say that the shipment quantity x must be greater or equal our minimum shipment. And this now has to be multiplied by our binary variable ship. But we're not done yet. In order for this to work, we need to make sure that this ship binary variable is really set to 1 if we ship from a plant to a market. Currently, it can always be 0. Why should it be 1? So we need a big M constraint. For this, let me add another scalar value and call it big M. And now we need another equation. Let's call it the maximum shipment equation. Max ship for all plants and markets. So maximum shipment. And how does this look like? Well, we start again with the name, max ship. And for all plants and for all markets, we want to say that the shipment quantity must be lower or equal to our big M value multiplied by our binary variable. Okay. And how do we set this big M here? Well, one way would be to look at the capacity and the demand. And of both, we take the maximum value and compare these values. And from these both values, we take the minimum. This is the maximum shipment we can have in our model from one city to another. So in GAMS, we can do it like this. We say big M is equal to the minimum of, this is done by the S max operator, which gets the maximum value of something. So we look at our parameter capacity for all plants, and we also get the maximum value for the demand parameter here. So B. And that should be it. If I click on run now, I will hopefully get an error. Yes, because I also, of course, need to change my model type here. I still have an LP here, but it obviously needs to be a MIP now, because we're using discrete variables with this binary variable here. Okay, let's try it again. Seems to work. All right. Maybe we can have a look at the objective function value here and change the minimum shipment. And let's see whether the objective function value changes. Oh yeah, it changed. And now we of course want to have the second slider here for this minimum shipment scalar. So let's start the configuration mode one more time. And we go to the widget section again. Now we have our second scalar symbol here, the minimum shipment. We want to have again a slider, label it by select the minimum shipment. Minimum value of 1 theoretically makes sense. Maximum value, let's say 350. Default value should be 100 and the step size of 1 is all fine. We save it again and go back to the base mode one more time. And now, after loading our default values, we should now see two sliders here in our input widgets. Now, we can play around with this, solve the model, and we see I set the minimum shipment to 198, and my output it says no value is below this 198. So this works. Okay, I have tried to show you with a very tiny model, to be honest, how you can quickly create first prototype of a Miro application. Of course, you can invest much more time and create, for example, more complex graphics. For example, if you look at the graphic from the beginning of this presentation, this is from the same transportation model, which just has been further developed. For example, a symbol containing latitude and longitude information was added to the model so that we can see the results of our optimization on a map. Now, let's say we are happy with the first prototype of our application and we want to give it a colleague for a first review. How do we do this? Well, we can deploy the app. Deploying a Miro application means to generate a self-contained file that has everything you need to distribute it. You or others can import this self-contained file and use it in a personal library. So, as I said, everything is self-contained in one file, and this is also platform independent, so you can also use it on a Mac or Linux. When you installed Miro on your computer, you can open it and you will see your personal library, which will look like this here. Miro comes with some example applications, which you see here, and one of them is also this transportation model containing the map. Right, deployed apps can also be put on a server where they can be accessed via smartphone, tablet, or any modern web browser. But at this point, I don't want to go too much into detail here, so I come to the end of this presentation. I hope you enjoyed it a little bit, and thank you very much for listening. Goodbye.